So in this section, we are going to log into our AWS account, and we are going to review the current auto scaling that we have. Then we are going to create a load balancer and connect it with the auto scaling. So now auto scaling and the load balancer can start communicating or work together to provide high availability resources for our end customers. So the first thing I want to do is to log into my AWS account as an IAM user. Remember, it's not advisable to use your root user for your day-to-day activities. So for this reason, I'm going to be logging in as an IAM user. To log in as an IAM user, you only need 3 items: the account number, your username, and your password. If you have multi-factor authentication enabled, then you also have to provide the MFA code that your system generates, or the multi-factor authentication application generates. So you also have to provide that. But I don't have that enabled, so that's why I only need 3 things: my account number, my username, and my password. So now that we are on the account on our AWS console, the next thing I want to do now is to go to my EC2. Both the EC2 instance, auto scaling, and elastic load balancer, all of them are under EC2. You can see that currently we have 2 instances running. We have 2 instances running. So what I want to do now, I'll just quickly terminate these 2 instances. Terminate them. So remember, we also have auto scaling that is running as well. We have our auto scaling. You can see we have 1 auto scaling. So the auto scaling is going to create our EC2 back for us, because we have a 1 minimum instance that must be running. So the auto scaling, since we terminate the 2 instances, so if we look at it will receive a signal that, oh, the 2 instances have been terminated. Then it's going to spin up another instance, but this time it's going to spin up 1 instance for us. You can see the activities of the auto scaling by going under activities, and you see what the auto scaling is doing currently. So while we wait for the auto scaling to, let me go back to the instance. Let's see if the auto scaling has spin up a new server. Okay, it hasn't spin up a new one. Let me see. Dashboard. Okay, it has not spin up a new one, but it's going to spin up a new one. But while we are waiting for it to spin up a new one, let's go and create our elastic load balancer. So to create an elastic load balancer, the first thing is to open your EC2 instance. If you are not currently, EC2 page, if you are not currently on that page, you open your EC2 page, and you can get to that by searching for it, or if you have visited it recently, you will see it under recently visited. So you can pick from any of the 2 to view your EC2 page. So once you are on the EC2 page, when you scroll down, you will see under the load balancing, by the left hand side, you will see load balancers. When you click on it, you see we don't have any load balancer currently running. So you can create a load balancer, but load balancer really need one thing. It needs a group of instances to route traffic to. So remember, the way load balancer work is that when you have your load balancer, it's going to be routing traffic to all the instances that you have. So the first thing you want to create is that you want to create a targeting group. This is called a targeting group. And it is this targeting group your load balancer will be sending traffic to. So to create the targeting group, what you need to do is under the load balancing section, click on target groups. So when you open that, let me delete the one I have before so that doesn't confuse us. Okay, so you can see now the targeting or the target groups is empty. So the next thing is to create our target group. You can use your load balancer to target different type of group. You can either target by IP address, you can target by instances, you can target Lambda or application load balancer. But for this case, I'll be targeting instances. So I'm selecting the instance. Then after that, scroll down, give your target group a name. You can just call it Coffee Server CG, meaning target group. When you are sending traffic from your load balancer to the target groups, you need to specify what port. Remember when we discussed about ports? Ports is just like a door. Just like a door. You need to specify what port would or should the load balancer use. What port should the load balancer use to communicate with these servers? We have a lot of ports. We have almost 65,000 plus ports. So you have to specify this precise one out of this 65,000 plus that the load balancer will use to communicate with these target groups, so that whenever the load balancer wants to send message, it knows the ports to go to. It knows the ports to use. Ports is just like door. Just like you are sending message or you are sending somebody to go and visit or to go and do something for you in your house. You have to tell them which door should they enter through. Maybe they should enter through the back door, or they should enter through the front door, or maybe they should enter through the window. So you have to specify. So that is why the load balancer, we need to specify which port, and we are going to go with the port 80. So that is why we are selecting port 80 here, and the port 80 protocol is HTTP. In a real life scenario, port 80 is okay for load balancer with the instance, but if you want it more secure, you can use port 443. But port 80 is okay because both the load balancer and your instances, they are inside the same private network. So it's okay to use port 80. And the IP type that we are going to use here is IP4. Then inside which VPC are we creating our load balancer? So I'm going to use the default VPC. And this protocol version, just select HTTP1. And for fcheck, just leave it the way it is. If the developer or who developed the application tells you that, hey, he has one of the file, he created one of the file for you called health check. And if this file is to make sure that all the server or the application is running fine. Now, if you want to know if the application is running fine, just go to this page. And if this page is opened, that means the application is running fine. Then you can specify the page here. You can specify that page here as, okay, this is the page that the developer said I should go to whenever I want to see if the application is running fine. But otherwise, just leave it with splash. If the developer tell you something like this, you can put this. But otherwise, just slash is fine. Meaning that anywhere you visit, if you visit the home page, once the application is open, that means it's working fine. So this is all you just need to put for your load balancer, your target groups. So for the target group, we have the instance, we have the name, we have the protocol, and we have the VPC. And that is all you just need to do for the target group. So I'm going to clear the screen and I'm going to save this. So now you can see our auto scaling has created 2 servers for us. It's created 2 servers for us. So the 2 servers now, we are going to be adding them. We are going to add those 2 servers to our target group so that the load balancer can start sending traffic to those to the 2 servers. So I'm going to create it. Now, what we've created here is not the load balancer, it's just a target group. So once we have our target group, we can now go back and create our load balancer. So let's go. The target group that we created, we need to add the 2 instances under the target group. So if you go here, you can say register target. When you select it, you have to do include as pending below. So then you can now register it. So now you can see now you see we have 2 unused. It's still initializing. At the end of the day, once everything fully initialized, we want these 2 that is showing unused, they should be showing FD. So the 2 should be here and the remaining should be 0, 0, 0. So it is if they are showing FD, that is when our server is ready to be communicated with by the load balancer. So it's going to automatically go to change to FD by itself, but because we just created it, it's going to take some few seconds or minutes for it to go from unused to FD. All right, so let's create our load balancer now. This is target group. So to create a load balancer, click on the load balancers under the load balancing. Then create a load balancer. There are multiple types of load balancer. We have the application load balancer, network load balancer, gateway load balancer, and we have the classic load balancer. This classic load balancer is a previous generation, so we don't really need it again. AWS is going to decommit. They are going to this is coming to an end of life very soon. So it's for old people that start using AWS before they create this story. So AWS have advised them to move to either one of these 2. So we are not going to be bothering ourselves with this classic. The one that we are going to be working with is this application load balancer. So the application load balancer, you can see it works with HTTP and HTTPS. There are cases that you can use this, and there is a use case for this. If you are targeting, if you want to route traffic to different protocols, like you have some HTTP, you have some maybe pinging, ICMP, you have some SSH, that you are not only sending traffic to web browser, then this should be your load balancing. But if you are only sending traffic to a web browser, then your app is application that you are going to use. So we are picking an application, to web server, not web browser. We are sending traffic to web server. So we are picking the application load balancer. We're going to give it a name called Coffee Load Balancer. And it's going to be an internet facing. Internet facing just means that it's going to be between the public, where our users are located, and our application. So this is where the load balancer is going to be. If it is private, that means, let's say this is our load balancer. Let's say this is our private server, private network. You can divide this private network. When we get to VPC, we talk about this. You can divide this private network into multiple. Maybe we have one here, we have one here. And guess what? You can have a load balancer in between here that is sending traffic to these people here and is collecting the traffic from here. So we can call this one internal. But if the load balancer is between the public, your end user, and your private network, then it is called internet facing. So it's going to be, we are going to select internet facing, and this is going to be IPv4. Then the network mapping. Make sure that you select the VPC where you want the load balancer to be located. If you don't know anything about VPC, don't bother about it for now. We are going to discuss this under networking. So you can check our networking video if you are watching this on YouTube. So you want to select which of these availability zone do you want the load balancer to be able to send traffic to. For now, I'm going to select all of them so that the load balancer can actually communicate to all the subnets. Inside the availability zone, currently I only have one subnet inside each of the availability zone. If you have more than one subnet inside the availability zone, then make sure you are selecting the one that is publicly accessible, which we normally call public subnets. But currently, all these subnets, they are publicly accessible and they are all public subnets. The security group, I'm going to go with the default, but in reality, in real life scenario, it's always good to create a separate security group for a load balancer. Then here, the listener and the routing. This is where the load balancer is going to be listening to and is going to be routing traffic to. Remember, we created what is called a target group. And it is that target group that we want the load balancer to be sending or routing traffic to. So we are going to select the target group here. Always make sure that you select the right target group. Otherwise, you'll be sending traffic to a wrong target group. But for this, we only have one, so it's easy for us. So we just select that one. And remember, when we create our target group, we said the load balancer should use port 80. So make sure that you are selecting the port 80 here too. And with that, that is everything we need to create for now, at least for this basic. You remember yesterday when somebody was asking me about how do we protect about botnet, that I was talking about web application firewall. And you can see this is where you can select it. Like, hey, I want to include web application firewall so that it can be in front of the load balancer. But for now, I'm going to remove it for this basic configuration. When we get to solution architect or under security engineer, we are going to be discussing this in full. All right, so this is everything. Just create a load balancer. Okay, the name of our load balancer has to be all lowercase. Let's give it all lowercase, and there can be space in between that. They can be spaced like this. So all of them have to be one word. All right, so I'm going to create this. Create. So now we have our load balancer. So currently we have a load balancer.
Yeah. Can I ask a question real quick?
Yeah, go ahead.
Looking at the region that those availability zones, those are different regions, right?
No, it's the same region. Availability zone, all availability zone that you see, they are availability zone within the same region.
Same region. Okay, but different location.
Yeah, they can be. So when you say different location.
So what I meant by that is that because it's like there is a those subnets are in different location within the availability zone.
Yeah, so yeah, they are in different availability zone. One is in US is 1A, one in 1B, 1C, 1D, 1E, and 1F. They are all 6 in number in different location. Yeah.
So it's like we're having the instances in all of these zones. So in case one fail.
Currently, we are not having instances in all of those zones. We only have in 2. But in a situation whereby if our auto-scaling group creates instance in any one of them, then we have a load balancer node in there that can be routing traffic to it. What we discussed so far under load balancer is just a tip of the iceberg. If you go under solution architect, that is when we go deeply into load balancer and show you how load balancer is actually working. Because when we say that, look at this. When you say we have a load balancing here, and here we have a target group, and the load balancer is sending traffic to all of these instance. Remember, this instance, they might be in different availability zone. This one might be in 1A, this one in 1B, this one in 1C, this one in 1D. And all of these availability zone, the load balancer will create like a node, like a small node, which is like a small server that will be monitoring this availability zone. And we do exactly the same thing for all of them. But for this basic for this solution cloud practitioner, you don't really need to go deeply into this. This is what they call advanced.
Is the node like sensor?
No, it's not sensor. It's like normal server, but it's of a small capacity. And the only thing it does is that it's actually the one that is monitoring that availability zone. So this major load balancer, when it receives requests from the end user, the user sends request to the load balancer, which is like a master node. And the master node now will look like, okay, which of the node is available? Like, oh, this one is available. Then it will now send the nodes to this node. It will send the traffic to this node, and it is this node that will be sending traffic to all the server in the same availability zone.
Okay.
Yeah. So, but we are not going deeply into that because that is under solution architect. The main purpose for the cloud practitioner is just to even know, okay, this is availability zone and this is what it does, or this is the function. We don't even expect to like go into the console and be creating it, because the solution, I mean, the cloud practitioner is just for you to have the basic knowledge of the services.
Okay.
All right. So now what we have done so far is that we've created our target group. And inside this target group, we have two instances. And now we've created our load balancer, elastic load balancer. So, and the elastic load balancer has been linked to the target group. So both of them can now be sending traffic. I mean, the elastic load balancer can now be sending traffic to the target group, which on port 80. So now let's go and see, is this actually working? So if you go back to our instance, let's go to the instance for now. These two servers that are running, let's pick one of them and let's see whether our web server is still displaying on them. So let's pick this. Let's put it here. Oh, good news. We still have our web server. Let's pick the second one. So I'm going to go back. Remember, this one is 71. It ends with 71. Look at it here. It ends with 71. Then the second one ends with 185. So I'm going to open a new browser and put that one there. So both of them are still showing our web server. So the problem now is that we can't be sending these two IP address to our end user, right? So we want the load balancer to be the one picking between this 71 and the 185. So what we're going to do now to test our load balancer is that let's go to the load balancer. Let's click it to open it to click. Then you will see what is called DNS name. When you select the DNS name, if you paste it in the browser, it should also show our web service, our website. Let's see, is it fully running? Let's see. Yeah, it's active, so it should work. If it does not work, we just need to check our security group. It's using the default security group. Does the default security group, okay, it should work since this is default security group. So what I will just do, let me edit that default security group because it's using this. That might be the issue. I'm just going to remove that and say go on. I'm going to remove this. I'm just going to say use all traffic on port 0, then save it. Yeah, so what I just did there, I just changed it was using a security group before, so I just changed it to, and besides, there's no even need of changing. You can see that it's actually showing, okay, let's just refresh. Now you can see now, it's now showing our web server. So now, instead of we going to either one of these IP address, we just need to go to our load balancer. So the load balancer will now be the one that will be picking between the two web servers that we have. Will be the one that is picking between web server that we have. So now the end user will not know which of the web server is their traffic sending to, but the load balancer is now the one that is distributing the traffic between the two web servers. If we want to know which of the one that the web server is sending traffic to, we can actually know. We just need to go and do some modification, like the two server. We just need to enter into the two server, put some information there that will let us know which of the server we are actually communicating with. But I think that is not really necessary, but we can actually do it. So if I go here, pick one of them, connect to the server, I can actually go to the website that is displaying and just put a wording here. And that wording will be showing us, okay, whether it's communicating to server 1 or server 2. But I'll just leave that for another day. So this is the first stage.
So,
what we've done now, yeah, go ahead.
So you said you put the word on the web page itself, and it will show if it is communicating to, if it is the server that is being communicated to.
Yeah.
In the search bar or just on the URL?
So you know these web servers, that what we are seeing right now on my screen is just a file that they put some code. Is a file with code. So
Yes.
I can actually go to that web server, go to this file, and either change this about us to about me or about server 1, and just change something there that whenever the load balancer route to this server, you will know that, okay, it is this server that it is talking to. And if we write to another server, you know that it's the second server that it's talking to. That's what I mean. You want us to go to that route?
I mean, it would be fun to see it. Is it from the source code of the page?
Yeah, from the source code.
That would be fun to see.
All right, let's see. So I will just quickly connect to this server. I'll just connect. I'm not going to be using my my VS Code now. I can actually, let me see, can I connect from here? I doubt it, because I don't have, I doubt it's going to be connecting from here. Oh, fine, it's connect. So now I'm inside the server now. So if I go to, remember where we put the file yesterday is var www.html. That is where all our server is. So if I add cd into that file, then I do ls. So these are all the server that you are seeing. If you go to the web server, I mean the website, you will see about us, blog, coffee,
Yes.
contact, and index. Let me change this about us. Let me go inside this file, and I'm going to quickly do something there. So to go inside that file, I can just do vi index.html. So this is what you are seeing here. What you are seeing, all these things that you are seeing, these are the code that are displaying those things. These are the code that are displaying those things. So if I want to modify this now, all I just need to first do is to press insert. Your key insert. When you click on the insert, look at this place. It's showing insert.
Yeah.
Look at it. If you click insert, it will show insert. Now means that you can modify this document. So if I scroll down on this document, let me show you. You see this here, from here to here. That is what is displaying what you are seeing here. So if we change, you see home, about us, coffee shop, blog, contacts. This is what is displaying them here. If I change the about us to the IP address of server 1, if I change that to the about us, I'm changing it to IP address of server 1. So this is the IP address. I'm just going to copy it. You can see. Then I'll click on escape, then colon WQ. You can see it here. Then enter. It's going to save that file. This is one. Remember, I did not change the second server. It's just one server that I changed. So let's go back to our coffee. If I refresh, you can still see, we are still seeing about us. Refresh again. You see now,
yeah,
we are seeing the IP address.
yes.
So what that tells you is that this website is actually serving from the server that we changed the IP address. If you refresh again, it will be serving from the second server.
Okay.
So that is the purpose of the load balancer.
So once you refresh it, it switches by itself to different.
So the refreshing is just like when you refresh, it's making another request. It's just like the first one. Let's say I'm the one that opened now. I press enter now. This is me. If you visited the site, it's like it's requesting for you again. So now it's like two different people requesting for the information. So that is why when you refresh, it gives different one. When you refresh, it gives different one.
So that's what happened at the back end whenever we refresh.
When you refresh,
it's
yes,
just going to try
it
to
will
find the same
go and fetch
information
the
from
server again.
another source server.
Yeah, yeah.
Okay.
So most of the time you don't know, you just keep on browsing. When you press coffee, the traffic is coming from the back end. And when you press show, it's making another request. So what now happens is that developers, they have a way of making sure that their websites run very fine, and there is a lot of things that go behind the scene. We might configure it so that if you visited the website for the first time, if we pull the information from server one, we might make sure that anytime, maybe in the next 1 hour, if you try to make any request, it's going to be getting your information from server one. That is what we call in load balancer, it is called sticking. It will stick you to that particular server so that it's not bringing your information from different server. So all of these are advanced. All right. Any questions so far?
I'm sorry, I had a quick question. So,
Yeah, right.
you explained that a load balancer can like work with multiple AZs, but I was wondering if like it's like with multiple regions, like for example, a big company like
I'm not getting your question very well. Can you speak a little bit louder?
yeah. So I'm gonna use an example like Google. If somebody
Okay.
in Europe is trying to access like just type in the DNS Google and like you said, it's to go to a space like it's go to a load balancer, then direct the traffic to a to an instance in a specific region. I was wondering if one load balancer can work with multiple regions.
Can work with multiple regions.
Yes, like for like Google is big, right? And they have customers all over the world.
Yeah.
And yeah, so for latency, they might have instances in region one or like US East one or like US South Asia two. I mean South Asia two. So can a load balancer connect to the instance in South Asia two and US East one? Can they work together like with the same
Yeah.
DNS?
Yeah, so it should be able to work. That's a very nice question. But let's test something out. Let me show you something here. When you are creating a load balancer, it asks us a question that let me pretend as if I want to create a new one. It asks us something here. he said you should pick an availability zone inside a region. And when we get to what's it called? When we get to VPC, you will understand that VPC does not span across multiple regions. VPC is only within a single region. So everything you deploy inside that VPC, load balancer, EC2, everything you deploy inside that VPC is within that VPC alone. It can't span across multiple regions. So the question that you have that can a load balancer span across multiple regions? Here it is answered here. It is answered here because we cannot use a load balancer in US East 1 to route traffic to application in US East 2. Because when you select the load balancer, you have to specify where are your applications, and it is only this place you'll be routing your traffic to.
All right. So what, like if a company like Google, like how do they have, is there a specific AWS service that can route traffic across multiple regions?
Yeah, so
How load balancer does.
yeah, so there is a lot of things that go into that. Let's say you have an application here, an application here, an application here. And let's say this is VPC 1, VPC 2, VPC 3, all of them in different regions, right? So there is something we are going to discuss under security, under networking, called transit gateway. This transit gateway, wherever the traffic is coming from, it will take the traffic and it will route it to wherever it should go. Let's say you have a user in Europe trying to communicate to your application. They are still going to be communicating to your load balancer, wherever the load balancer is. All they just need is the domain name. All they need is the domain name. So you can see users from Europe, user from Asia, user from Africa, user from North America. All of them, they can communicate to this application. So the application, the load balancer, so the load balancer is the one that will be routing the traffic to the server. So you can have a server here, you can have a server here, you can have a server here, right? But at the end of the day, all this, if there is going to be multiple load balancers, if there's going to be multiple load balancer, there can be multiple load balancer in different regions. So we have what is called a network load balancer, and you can also have a load balancer that is routing traffic to another load balancer. That you can see it under here. You can see it when we select the routing. Let me see. somewhere here. No,
But
when we
that
select
that's
it's
kind of
under target group. It's under here. You can see it asks which what is the basic? Are we choosing instance? Is it going to be routing to an instance, or is it going to be routing to an IP, to a load balancer, or to another load balancer? So here you can pick a load balancer. So when the load balancer is routing traffic, is routing it to another load balancer. But there is, if you have multiple people in different region, there is a way that you can like connect them together, that all the users, they will be having, all the user will be sending traffic to the same domain name. There's going to be like an hierarchy, like a general load balancer. This load balancer can have 4 load balancer under it. And the major load balancer will send traffic to all of these load balancer, and then the load balancer will now send traffic to the instance. So for big company like Google, the complex, I mean the system design, that's what they call system design. The system design might be more complex, but you can actually, but one load balancer can only communicate to resources in that load balancer. I mean, in that region. The load balancer does not span across multiple regions. It's a regional based resources.
all right. Thank you. Sorry for
All right,
diverting.
let's go for our 5 minutes break. When we come back to link, or maybe we can quickly do it so that all of them goes on one video. So now the next thing for us to just quickly do is, and I'm going to cut some of this question off. I want to reduce the, or maybe I should, do you guys want me to leave it or I should cut it off? I want to reduce the size of the video. So the next thing is, let's connect the load balancer together with the auto scaling. So if you want to do that, just go to your auto scaling. You can pick the auto scaling that is already existing. You can do edit. No, not there. Edit. No, this is a, let me see, is it under this one? Networking, wireless templates. No, not this. Go back. Yeah, load balancing. Edit. Then I can now select a load balancer. So I'm going to pick application load balancer. Then I'll select the load balancer that I want to use. Then I'm going to update it. So now we've connected the auto scaling together. So the architectural diagram that we have now is this. We have our auto scaling that is monitoring all of this server. And remember, we have all of this server that's going to be in a target group. And then we have the auto scaling, I mean, a load balancer here. You have a load balancer here that is sending traffic to this instance. And we have our user that are sending traffic to the load balancer. So that is what we have now. So in the, let's go for our 5 minutes break. When we come back to review some knowledge check, and we go to the next topic.